So here's a quick OpenStack Helm all-in-one demonstration. Let's get started. Okay, the first thing I did was start with the OpenStack documentation. So I went to this link here, which is the OpenStack documentation for Helm. And then what I did was I scrolled down here to the all-in-one installation folder, and I started looking at the system requirements, and then I went through this whole procedure. My particular system is using a simple laptop with 4 cores, 8 gigs of RAM, and an internal hard disk. So I went through each one of these steps, running all these scripts and going through this procedure. So I thought I'd walk you through it. So the first thing I did was prepare a system for this. So if you can see, I've got basically a 4-core Dell laptop I'm running this on. I've got hyper-threading enabled, so I've got 4 cores with 8 logical cores. So I've got multi-threading enabled. I've also got 16 gigs of RAM, and I've got an internal 1 terabyte hard drive, which I wish was faster, but it does the job. So I'm only using 24 gigs of the 1 terabyte disk, which is extremely lightweight. So the next thing I did was install Helm. And so when you install Helm, you end up with 2 directories, the OpenStack infrastructure directory as well as OpenStack Helm. You do most of the installation here within the OpenStack Helm folder, and there's a bunch of scripts that help you. So if we go ahead and look at those. You can see there's a bunch of scripts and they're ordered step by step. So you start out at the 0 script and you work your way up to step 19, which is the use it script. The only one I skipped here was Cinder. I actually love Cinder, but I wasn't sure if I had enough resources on my system to run it. So I went ahead and skipped it. But I'm running everything else, including Ceph. So let's go ahead and take a look at one of those particular scripts. Let's take a look at Glance, for example. So one of the things you can see is the first thing these scripts do is, and this is pretty much common across all of them, they do a make pull images. So it's going to pull down the images for Glance, and then once that's completed, it's going to use the Helm command to install this particular chart. They call it a chart. And then once that's launched, it's actually going to go into a wait state by running this wait for pod script to wait for it to finish. Now, what I found is in my case, maybe it's because I'm on a slow system, the wait for pod script actually finishes before the initialization is complete for some of these services. So I found that I use the kubectl command to check the status. It's a little bit more meaningful. So if we scroll down, you'll also see that in particular for Glance, we're going to go ahead and create a Glance image for the Ceros operating system, which is just sort of a sample lightweight Linux OS image. We could also run bare metal services with Magnum, but I haven't set that up yet, so I haven't launched that particular chart. So we'll go ahead and clear that out. So the next thing we'll do is get familiar with the Helm command. So if you run the Helm command, if I scroll up here, you can see a common use for the Helm command is Helm install. There's also Helm list. So let's list all the services that are running and see what state they're in. So you can see I've launched a whole bunch of services by following all those scripts I showed you earlier. And they're all in a deployed state, which is great. You can also see which namespace they're running in, whether it's OpenStack, the Kubernetes system namespace, or Ceph. Ceph is actually running in a separate namespace for the most part. Okay, so the next thing you might want to do is, because the deployed state is great, but you can't tell whether the services are fully initialized or not. So what I do is I go sort of one level deeper to start looking at and inspecting the services. And to do that, we use the helm inspect command. So you can type helm inspect Nova, for example, to inspect the Nova deployment. So if we scroll down, if I go past these labels here, one thing that's kind of neat is you can see all the Docker/Cola images that we loaded to instantiate Nova. And for those of you OpenStack experts out there, you'll see the familiar OpenStack flavors that are typically created: the tiny, medium, small, large, extra large, etc. For this example, we're actually just going to make use of the tiny flavor, which is to use 512 gigs of RAM, or megs of RAM, I should say, one virtual CPU, and a 1 gig virtual disk. So there's other stuff in there, but we can skip that. So the next thing I like to do is get a status for the individual pods and make sure all the services are up and running. So I run a kubectl command for that. So you can get it for all services or just hone in on one for the Nova. So first thing I do is I look at all the services, see that they're all in the running state. If they're not in the running state, you need to kind of take a look at those individual services even further. So let's focus on just Nova, for example. So there's a bunch of Nova services that are running. We could take a look at Nova Compute. Let's say, for example, the Nova Compute wasn't running correctly and it was still showing as it being in the init state or a backoff state or something. The next thing we would do is dump the logs. Now, dumping the logs requires that you export the pod name and then use the kubectl command again to dump the logs. So let's go ahead and do that. So we're going to do this for the Nova Compute service. So I got two commands I'm going to run. I'm going to export the pod name, and then I'm going to run the kubectl command to get the actual logs for that service. Now, the logs for this service are kind of short. It's just a single error that it encountered during the initialization. And it seems to overcome that because it's now running in a running state, which is great. So I think this is okay. But it's a nice thing to do to be able to check those logs. So the next thing you can do is look at the last script that we launched, which is the use it script, which actually launches a bunch of heat stacks from the command line. So let's go ahead and take a look at that use it script. Go ahead and more that. If I scroll up, you can see that we're actually going to create a heat stack to create a network. It's actually a public network, as you can see the public name there. Next thing we're going to do is create a subnet, and the last thing we're going to do down below is create a key pair, and lastly we'll create a virtual machine, and we'll assign it a floating IP. So there's a whole bunch of stuff here going on. We can break out of that, and now we've got a Cirrus VM that's launched as a result of that heat stack, and we can go ahead and try and connect to it. So we'll do an SSH to the floating IP. And the password is CubsWin with a smiley face. And now we're at the Cirrus virtual machine prompt. And we can see if DNS is working. So we can go ahead and ping google.com, and that works, so that's great. So we have one instance loaded on this cloud that's running on my laptop, and we've got full access to the internet, which is cool. So now let's switch over to Horizon and see how this all looks like from Horizon. So what I'm doing here is I'm logging into Horizon using this 172.17.0.1 address, and I had to go to port 31,000, which is how it was initialized. So I normally show up in the project folder, and the overview is where you usually start out. You can see I have one instance running with one virtual CPU. I'm using 512 megs of RAM and one floating IP. You can also look at the instances that are running. We've got one instance running, which is using that tiny flavor that I talked about before. We've got a floating IP set that we used, and we were able to SSH into that. We've also got one glance image set up for the Cirrus 64-bit image. We should have one key pair. And we could also look at the network topology, actually. If we look at the network topology, see we've got a public network, we've got a neutron router, and we've got a private network here with one virtual machine. And we could open that console and see the same view that we saw from SSH, but I won't bother with that. And that's pretty much it. You go to the admin section and look at a bit more information. You can look at the system information, for example. Look at all the services that are running, the compute services, the network agents, and orchestration services from Heat. So it's pretty simple, and it's a nice way to interact if you like. So that completes this demo of OpenStack Helm, and hope you enjoyed it.